Hello everyone, so in this video I'm going to show you how you can implement the closed form solution of linear regression that we discussed in the last video, right? So pretty easy, not very difficult. All we need is to just implement this formula to get our right set of theta for a given data set, right? So let's get started and so the first step is you need to generate some data set. So I'm using this make regression function available in sklearn to generate this dataset, and everything else we are going to write from scratch. Okay, so let's see, we have 400 examples. So let's say what is the shape of x, and let's see what is the shape of y, right? Okay, so x is having a shape of m cross n, which is fine, but y is a vector, right? So what I'm going to do, I'm going to reshape y in the form of a matrix, right? Because when we did here, we say that y should be a vector of m cross 1, right? So I'm going to resize it, reshape it. So y equals to y dot reshape, and the number of columns I want is should be 1, right? Okay, clearly, which is good. Now the next step is we want to normalize our data set. So let us do some normalization, and let's say x minus x dot mean and x dot standard deviation, right? So I subtract the mean and I divide it by standard deviation, and let us now visualize how the data set looks like, right? So let's create one figure, and let us scatter x and y, and let us give some title normalized data, and let us call the show function, right? Okay, so this is how the data looks like, and now we have our x matrix, and the next thing is this matrix, right? For this data set I want to predict one boundary like this, right? I want to predict one line like this. So for that I need two parameters, theta naught and theta 1, and then I will compute this value x theta minus y square, which is going to be my loss for the entire training data set. Why? Because we saw that x theta minus y gives us one vector of this form, y predicted I minus yi, and if we square this vector up, right, so we get sum of squares for every part, right? So let's say this is 1 2 3 and this is 1 2 3. So this can be written as x theta minus y transpose into x theta minus y, and we saw that when we take the derivative of this and we equate this to 0, we get theta, which is equal to x transpose x into inverse into x transpose y, right? So I'm going to use this formula, right, for computing the right set of parameters theta for my line. But here clearly my data set is having one dimension and theta is having two dimensions, right? So theta 1 and theta 2. So I want to make x in two dimensions. So what I'm going to do, suppose these are my x's, I'm going to insert one column of ones, so that x matrix has a dimensions of m cross n plus 1, and I already have n plus 1 parameters, right, cross 1, right? So this is going to be my theta matrix, right? So let us append some ones to our x matrix, right? So I'm going to create one column of ones. So ones is going to be np dot ones, which is going to be x dot shape 0, which means the total number of examples, and the column is going to have only one column, right? So next step is I'm going to generate x bar, which is my new matrix, and I'm going to stack these two matrices together, x and ones, right? So let us see the shape of x now. So it is of the shape 400 cross 2, and if I print this matrix, let's say only first 5 rows and all the columns, sorry, x bar, right? So clearly you can see that this is my 0th feature, this is my x naught. Okay, so this is my 0th feature x naught, and this is my first feature x1, right? So in every example I am going to have two features. One, the first feature is always 1, and here I have the value of the feature for that example, right? So why we have done is so that we can take this product x theta, right? And when you do this 1 x into some 1, so it becomes like theta 1, and you have a theta naught here, so it becomes theta 1 x plus theta naught, right? So this is the value of our hypothesis, h theta of x, or you can say it is nothing but y predicted. So y predicted minus y, square it up, you get the loss, right? So this is your x new matrix. And now I'm going to define two functions. One is going to be my predict function. If I know the value of x and theta, then what is going to be my prediction, right? So if I want to compute prediction for everything, it is going to be nothing but a dot product of x and theta. So x is this matrix which is of this shape m cross n, and theta is this matrix which is going to be of the shape n cross 1. So if you take a dot product, you are going to get a vector of this shape m cross 1, right? So x theta. So x theta is going to be this vector which is going to be a prediction, right? So simply you just need to take a dot product between x and theta, and you are done, right? Again, this is your predict function, and now you have the training data set, you have the predict function, and the one thing you need to define is how to get theta. What is the right theta, right? So I'm going to define get theta using the closed form solution, right? So this is the method which is going to accept your data set. There is no any other parameter like learning rate, nothing, right? So you can just directly use the formula and you're done, right? So let us see the formula, right? So the formula that we derived is this x transpose x inverse, right? So I'm going to say this is my first part and this is my second part. So I'm going to compute these two terms here. So first part is going to be a dot product between x transpose and x transpose and x, and second part is going to be a dot product between x transpose and y, right? And your theta is going to be a dot product between the inverse of the first part and the second part, right? So to compute inverse, I'm using the pseudo inverse method which is available in np.linear algebra module. So it is called pseudo inverse, and you take the inverse of the first part and you can multiply it with the second part, right? And just return theta, right? Okay, so this is it, and now let us try to test our function. So let us get the theta, which is given by get theta closed form. We give x, we give y, and let us see what is theta, right? So we are getting it should not be like this, right? So let us see if we have made some mistake here. Yeah, so for this thing to work properly, we should also convert a y into a matrix, right? And earlier I think y was a vector, but now y is a matrix, and clearly you can see, right, we are getting two values of theta. The second value is for the bias and the first value is for the theta or the weight, right? And now let us see how good we have done. So let us draw the plot once again, right? So this is our data, and this time I'm also going to plot x, and on the y-axis I'm going to plot the prediction, which is the predict function, which accepts x bar and the theta. And let us define color as red. Okay, so clearly you can see that we are able to get a line which is very well fitting to our original data set, and now you can compute your accuracy and whatever, right? So label equals to okay. So I hope this tutorial about closed form solution is clear to you. And what we did is we just implemented this formula that we derived in the last video, and that's it for this video, right? So alright guys, I hope you like this tutorial. Do not forget to like and subscribe the channel Coding Blocks India on YouTube, and stay tuned, I will be posting more videos on such topics. Thanks for watching, see you guys.